6.4, exponential growth and decay. So we've learned in previous classes about exponential growth, which refers to usually the growth of humans or a live species or something like that, where something's going to double each time, and so it's going to get larger and larger. But in previous classes, we've only worked with them in one variable, where one thing is changing, say, time. Now we're going to introduce something called separable differential equations. A differential equation of the form dy dx, so the change in y with respect to x, equals f of y g of x, means that there are two variables changing. So we call this separable. We separate the variables in the form 1 over f of y dy equals g of x dx. So what we did here is we divided the y function to both sides and multiplied the dx to both sides. We find the solution to this type of problem by taking the antiderivative of each side. So example 1. Solve y if dy dx is equal to xy squared when y is equal to 1 and x is equal to 1. So notice that there is a y and an x on both sides, and we need to take the antiderivative to find the general solution. So I'm going to start out by writing that this is dy over dx is equal to xy squared. And doing a little simplifying, I get dy dx is equal to x squared y squared. Now here's the thing. I need all my y's on one side and all my x's on the other. So I get, by dividing both sides by y squared, or multiplying by 1 over y squared, I'm going to get that 1 over y squared dy dx is equal to x squared. So these are going to cancel off. Now what I need to do is multiply both sides by dx. So I get 1 over y squared dy is equal to x squared dx. Now, when you want to integrate 1 over y squared, I do highly recommend to write it as y to the negative 2 dy is equal to x squared dx. I recommend to do this because it's much easier to visually see how to add 1 to a negative exponent than to try to deal with it being positive in the denominator. So now we're going to integrate both sides. And this one has the dy already, and the other one has the dx, so we're good to go. So the integral of y to the negative 2 is negative y to the negative 1 is equal to 1/3 x cubed plus c. Now remember from previous classes that we only need a plus c on one side of the equation. So we only need one constant. If you want to write plus c on both sides, that's fine, but they'd be different c values, and so you would add them together and you would just get one constant. So now we're going to write this so it's a little neater. And so this is going to be negative 1 over y is equal to x cubed over 3 plus c. This right here represents our general solution. And now what we're going to do is we're going to use our initial value to determine c. So we have that our initial value, if we go back to the beginning, is 1, 1, because x equals 1 and y equals 1. So we just plug those in, and we're going to get negative 1 over 1 equals 1 cubed over 3 plus c. So I get negative 1 equals 1/3 plus c. I'm going to subtract 1/3 from both sides, and I'm going to get negative 4/3 is equal to c. So now what we need to do is rewrite our equation to find the particular solution. So we get negative 1 over y is equal to x cubed over 3 minus 4 over 3. So negative 1 over y is equal to x cubed minus 4, all divided by 3. And there's a property that says if you can cross multiply, but there's a property that says you can flip both sides and it remains the same. Then I'm going to multiply both sides by -1. And sometimes they'll write it like this. Y is equal to 3 divided by 4 minus x cubed. And that's just distributing the negative into the denominator. Okay, now what I want you to try on your own is this problem right here. dy dx equals x over y when y equals 2 and x equals 1. So I want you to try to find the particular solution that satisfies that differential equation. All right, let's see what we get. So the first step, I'm going to multiply both sides by y, and I'm going to get y dy dx is equal to x. These are going to cancel. Then I'm going to multiply both sides by dx and get y dy is equal to x dx. The next step's to integrate. So we integrate both sides, and we're going to get 1/2 y squared equals 1/2 x squared plus c. And if you want, you can multiply both sides by 2. We're not going to do that yet. I like to plug in my value, but it wouldn't make a difference. So now we're going to use our initial condition, which is 1, 2. So we get 1/2, 2 goes right there, is equal to 1/2, and we're going to put the 1 right here. Again, that value goes here, and this value goes right there. So now all we need to do is solve for c. So I get 1/2 times 4 is equal to 1/2 plus c. So this is 4 over 2 is equal to 1/2 plus c. And the reason I didn't simplify it is I know I'm going to have to subtract that 1/2. So I subtract 1/2 from both sides, and I get 3/2 equals c. So now we need to write our particular equation. So we get y squared over 2 is equal to x squared over 2 plus 3/2. And then from here, we're going to go ahead and multiply everything by 2 to get y out by itself. So I get y squared is equal to x squared plus 3. Then you take the square root of both sides, and you get y is equal to plus or minus the square root of x squared plus 3. Now, this part is very important. We have to look back at our initial condition, and our initial condition is that we have a point at 1, 2? Yeah, 1, 2. So this takes place in the first quadrant. So notice that if I want to plug in a positive 1 and get a positive 2, I need to use the positive version of that. So I get y is equal to positive the square root of x squared plus 3. If this point happened to be like -1 or 1, -2, then I would use the negative value.